So DevOps is the practice of operations and development engineers participating together in the entire service life cycle, from design through the development process to the production support. So initially, I mean, people who come from dev background, you know that there was agile development, and you would use a lot of those tools. What happened a little later is, though the people who are agile in the development side of it, they also wanted to bring in equal participation from the operations side towards this agility, and they had this agile administration as such coming in. So we'll talk a little on that as we go along the skills and stuff. Thus, this DevOps was formed. Okay, so so I want to re-emphasize here. DevOps is a new requirement which also requires unique set of skills to perform that role. But each organization does that in their own way, which they feel which is appropriate. In a web scale architecture organization or the internet scale company, the internet organizations, the DevOps role is very clear. He's a guy who knows systems and its operations very well, but come with a solid set of but comes with a solid development background, and he knows a lot more tools than generally a system admin would know. When you say a system admin, you look more towards Unixes and servers and storages, but he would have to have things like your SCM, his bit of middleware, bit of DB, and much more, and much more, so that he is able to visualize this, because you need to have the the re-engineering work on this whole system sides of it in a very clear way. So that's how you create a DevOps guy as such. Okay, so the perfect storm, as they say. Now, what was this perfect storm? In the last slide we saw that, right? There was this agile methodology which had come in, and all the development work moved towards this agile methodology. Earlier we had waterfalls and various other methodology. So people moved towards into this agile methodology as such of development. Then these CIOs, if you ever talk to them, they always look at ways to bring down operational cost. Okay, they always find ways to how to bring down the operational cost. Now, to reduce these operational costs, by default, we know that we need to reduce the IT side of cost, plus the process side. When I say the people side of the cost, the process side of the cost, and the technology side of the cost. Now, to get in all these things, we had to re-engineer the whole operations as such, and that is where people start talking of lean IT services. Now, around this time of 2008, 2009, this was a time when cloud was actually booming as well. Though I should emphasize here, DevOps is just not for cloud alone, but it could be for any for the traditional IT as well. But booming of the cloud and the prominence of Amazon coming in a big way, the agile methodology of development, the tools for automation, then the theory of constraint, how to remove the existing bottlenecks. One of the standard examples of removing the bottleneck was, we all know there is a limit per server, right? Now, let me take an example of a server which has a Apache install, Apache web server installed on that. Now, if you look at that server, how do we know how many simultaneous connections can this particular server handle? Okay, so this leads to learning the system's bottlenecks, and this is what theory of constraint is all about. So if I could know how much of simultaneous users that a particular server would handle, then I can size it in a clear way, bring in automation apart from having the agile method. So all this kind of came together around 2009, and that's where this term called DevOps actually started coming in. Prior to DevOps, we had this word called automation, which always existed. So there was this question being asked, do we need to know in depth of OOPS? The answer is yes. Now what's happened is in your scripting world, we did, what is this? So if you generally look at the language as such, we know we could do procedural form of development, functional form of programming, and OOPS way of development. So earlier in our scripting space, we always done the procedural form of development and add some functions in that. Now this would suffice most of the world of scripting automation. But once we get into the world of DevOps, we ought to understand OOPS, and OOPS is used in a very, very big way in DevOps. So we don't have an escape from that. We don't have an escape from that. So so what happens is you need to understand your language at a pretty deep level. But again, see, we are not here to understand either C or C++ or Java. So those are going more in towards the app development. I'm not looking at app development. I'm looking at using language for automation. So many times, not many times, it's always that OOPS is definitely used as a part of it. So I hope I answer that. Okay, so now how would you become a DevOps? Okay, so this is what we get into and understand. Okay, so DevOps tools, scripting skills, coding skills, and process re-engineering skills. Now, what is that you require to be a DevOps? Okay, first and foremost, you need to understand the operations / systems domain. So what I basically mean, you need to know system administration. Either as I know you could be a developer who knows it, or as any other engineer, maybe a DB engineer. You as a DB engineer, you know it. As a network engineer, you may know it, or as a Linux administrator, you'll definitely know it. So this is a must. You need to know. You need to understand. You need to understand administrative operations and have that particular skill. Basically saying, you need to understand all those commands, your LSs, makedr, and then how to create file system, how to handle your LVMs, how to configure a network for your system, whatever that may be. Everything that you need to know. So that is one aspect. No second thoughts on that. Second, so many of the system admin guys today also have scripting skills. So when I say scripting, this is pure form of understanding your bash with sed, with awk, and of course knowing regular expressions. Yeah, so this is a must to come from, because you would still use scripting skills even though you may be using one of those popular languages like Perl and other things as such. And I also want to let you know, see, primarily today, DevOps is more Unix oriented, and I can tell you, DevOps is also Windows. Though we have not seen much happening in that space as of now, but you would maybe 1 or 2 years, 1 year or so down the line, you will have Edureka launching DevOps for Windows and DevOps for Unix, and we are primarily going down that line. At this moment, DevOps is all about using your development skills for Unix as such. So primarily what happens, yeah, you would actually looking at DevOps Unix engineers than actually DevOps Windows engineers, because using the skills at this moment I can't apply much into the Windows space. But Windows is coming up with their own way of handling DevOps in the Windows environment, which will come much later as such. As I said, so you know a bit of scripting, and definitely you should possess at least one full-fledged language. You need to know one language, either Perl, either Python, or Ruby, and this is what is present as such. They're using one of this to actually get into the automation space. And Python at this, I think, moment probably would be on top of the three languages. So anyway, we have examples, and so Google and Amazon being the biggest users of Python in their automation space. So maybe that's one of the reasons we are we hear a lot of Python and other things, but Ruby is definitely trying hard to catch up into that space. Sorry. So knowing one of these skills, so apart from knowing the skills, you need to know re-engineering, process re-engineering as well. So when I say process re-engineering here, see, we've always installed a system using a CD-ROM or any other way. Now, can I get into the space of unattended installation? Can I get into the space of unattended application installation? So you should look that into the this re-engineering in a holistic way. Example, and we've always used SCP to transfer files. Is there another way to transfer files? Okay, we understand that configuring, applying configuration to machines is just by copying. Is there another way to copy these configuration files? Is there another way to deployment? Is there another way to deploy? Is there another way to you package your own files as well? So this re-engineering skill is a must for you to really understand this whole space. Okay, so putting all this together, I know this is a lot, so I think Kishore is asking that same question, but you expect all the skill sets for the same guy. We can rather have a DevOps team, not a DevOps guy. Yeah, but yes, you can have a DevOps team. As I said, more and more, you might have heard this word called left shift. So when you start with an operations, right, you have the maximum number of people. You'll have your L1s and L2s and probably L3s and architects. And as you go down the line, all L3s would eventually get consolidated into an L2, so that we redeploy them or we reduce them and then put them into another application, another way. So the whole idea of DevOps is also to reduce on people count. though I know unless, as an example, I'll give you an example of my own experience. When I handled, Unix systems way back in 2000, for every 30 or 40 Unix systems, we had a we had one Unix engineer. Now, forwarding to 2010, for every 10,000 engineer, for every 10,000 systems, there was one guy to handle. So you can see the difference, right? So you take in a traditional enterprise world. If you had 1,000 to 2,000 systems, I'm talking about 2,000 and prior, 1,000 to 2,000 systems, you definitely at least had 5 to 10 engineers managing, but you don't see that today. And how do you how has this been reduced? This is through some automation way. So either there was a team which automated, and then they handed over to the L1s and L2s to manage it, or you had just had a good DevOps guy who could handle all of this together in an easier way. So you need to have a little more skills than you otherwise had. Yeah. So there is definitely a lot of things that you would want to actually gather to be a DevOps engineer. Yeah, and he needs to know a lot of things than otherwise he would know. We see now that the kind of skill requirements that we want, should you be a DevOps engineer as such. So as I said, Unix commands and scripting, your bash, your shell scripting, your coding, and now the other things you need to today add into your skill base is the configuration management systems, either Puppet, SaltStack, Orchard. Now even I don't know all of these. I primarily I invariably stick to SaltStack. That's been my base. But if I were to go to another place, maybe I may have to pick up Puppet and Chef. Then the other thing which you may have to know, which is there is no second options, but you have to know is all of these things. You should understand what is PXE, what is DHCP, what is DNS in depth. So there is no second thought in that. And there are other tools like Cobbler, which you may or may not want to add into your skill base. Okay, so we hear this term continuously called continuous integration and continuous deployment. Okay, so sometimes I feel the whole DevOps is created to just to do these two things. Not these two things, rather continuous deployment. That's what we get today. So what's all this about continuous integration and continuous deployment? It's as simple as that. It's as simple as saying that we want agile development. Now, when we say agile development, what we are looking at is, as an example, I'll give you. So imagine you are on the you are on web with one of your apps, and suddenly one of the business guys come and tell you that, hey, you know what? We need to add this feature. We need to add this feature. We need to add this feature into your website. Now, how do we go about doing it? So we know that we may have to make some changes in the backend in your DB. We may have to make create some business code in your app layer, and then we may have to make some changes, and we have to make some changes in the web layer as well. So if it's a web app, these three are the layers that you would kind of work. And if it's another application, there may be various other things. Now you need to code this, you need to test it, and you need to test. You need to code this. You need to package it. Test it, then package it, and then deploy. Now, in a traditional way, all this would have taken so many more cycles, right? It would take more than 2 to 3 weeks and things like that to get something moving in this. But here we are looking in days or sometimes in an hours. So example, one good example is I keep going back to that example of today all of the Amazons and the Flipkarts and the Snapdeals keep launching these deals day, right? And in a deals day, they expect so many users coming and all that. Now, for a deals day, there may be scenarios that you may make changes in hours sometimes to cater to certain demand and things like that. Now, how do you go about doing this? We can't do this through the normal procedural way of deploying applications. We have to go through in an automated way. So, so the automated today way is what we call as continuous deployment. And for this continuous deployment to happen, there are various tools that we are going to use. And in this situation, this the tools plus process plus some kind of development is going to come in to get this whole thing into a production deployment stage. Okay, so yeah, I mean it's pretty obvious what are the advantages of CI versus CD, right? And CD is the most fully automated way, but of course, when things go too much automated, there can also be its own risks as such. Like I very recently, Amazon lost, a couple of hundreds of servers' data wiped out by accidentally running a script. Now, so we also need to take care of that as well. So, but I know they would improve with everything, but you have this risk always with the CI and I mean, especially in case of CD as such, where everything is automated, including your testing as such. But CI works in a little more careful way, but again, you need to see speed versus speed versus time in how you want to handle it. So DevOps in real life, the Apple was one of the first companies to develop the DevOps team. But actually, what made DevOps into prominence is because of Yahoo's and Google's. Actually, they are the first to use this because their servers run into today not thousands. It's actually hit I think nearly 1 or 2 lakhs, if I'm not wrong. Definitely crossed a lakh of servers for sure. So having such huge numbers of servers, we have no other option but to go the DevOps way to do it. But have the other organizations, when I say other organizations, have the enterprises adopted it? Now that is the big market we are looking at. If we could adopt DevOps in an enterprise organization, we would then be creating a new set of space for us to and a set of skills to work on as such. So that's why this whole course has been designed, to see how we could adopt DevOps in an enterprise space. Yeah, so we all know now the benefits, right? The flexibility, the cost avoidance, the agility, which I've talked about. Accelerated innovation, yeah, may and may not be, but IT efficiency, big way. That's what is the whole mantra. The efficiency you get in the IT operation, that's unbelievable because automation brings in consistency and at reduced cost, and that's the greatest part of it. Okay, so this is how that whole picture looks like. How the DevOps is. So this is actually the CI/CD cycle. So we have the continuous integration, and then from there, once the package is ready, it goes to the the release automation engineers or the application deployment team. which actually manages the which probably could be the infrastructure people also. It depends on how the organization is. So there is the release automation team, then you have the infrastructure team, and the application team as such. Now, let me just before I wanted to. Okay. So if you were to split this, I just skipped a couple of slides, just to give you a little more meaningful way to organize the thought there. If you split your DevOps, right? So DevOps can be split into infrastructure automation, your configuration management layer, your CI, your basically CI and CD are kind of merged together, your CI/CD layer, and your monitoring layer. So we need tools at each of these layers to actually deploy your, actually create this the DevOps environment. So what we see, what we see here is each of these layers. Okay, so we have the monitoring, the infrastructure, CI/CD layer. I mean, of course, this is kind of merged, and you also have your configuration layer. So, again, though I'm trying to say there are 4 or 5 kind of layers, some of the layers can be integrated. So your infrastructure automation could be a combination of configuration management and infrastructure combination. Now here you see there is a CI layer and a deployment layer which is separate, but they probably could be merged. But your application monitoring is going to be another separate layer. So how each one designs, it's going to be slightly different. From my experience, we had a separate infrastructure automation layer. We had a separate configuration management layer. We had a separate the release automation or the continuous deployment layer, and we had the monitoring layer. So these were 4 separate layers, which I mean, from my experience, I'm talking of. So, but this could be different for different organizations and the way they are going to use them. Some could be merged, some could be standalone. Some may be only be using a configuration layer, they not be using an infrastructure layer. So it varies from organization to organization. Okay, so this is how it would look like. So what we are, expecting is, if you look at a general data center, life cycle, or what do you have? So you get in your servers, you plug the server from power and network point of view. Then you image your server. Now today imaging is 2 different things, right? You could image it with an OS or you image it with a virtualization layer. So you image that. Then you may create VMs or you may not choose to create VMs. Then if this was a web layer, you would probably attach to the load balancer. If this was a DB, then you would need to attach your web and your DB servers. And if this was a DB layer, you may have to probably attach a SAN or things like that. So now you look at each activity that you have to do. Now all of that gets into a configuration layer, and this is what your configuration systems management takes care of. And after that, you have to deploy all your apps and then do the full integration so that your apps is ready. So so the whole life cycle goes through provisioning, configuration, and integration in a production cycle. So I think I came here. So you now know what tools are to be used. Before that, let me check if there are any questions that are coming in. Okay, so as you now know, there are there are different tools for different layers, and this is how this whole layer fits in. So the infrastructure layer, your configuration, your integration, deployment, monitoring, and there are a couple of, so the revision control, SCM and virtualization, though they are not different layers, they could actually get into one of these itself. So that's how the whole space of DevOps tools is all about. So by now, I think you're clear with what the continuous integration and deployment is all about. So, so let me tell you the Puppet, see Puppets and the likes. So it is going to be Puppet, SaltStack, and Chef. And there's Ansible, which is also another popular. Now, these particular tools will come in only after the operating system has been installed. Because for all these tools have a client-server architecture, and if it's in a client-server architecture, there is an agent which gets into all your systems, and there is this Puppet server. Now, this can be only installed once your operating system is installed. So that is why I'm saying there are layers. Now, why I say there is an infrastructure layer is, why I say there is an infrastructure layer is the layer which installs your operating system or your hypervisor. So I need to be very clear with it. It installs your operating system or your hypervisor. Only if this is installed and configured can I then start with your Puppet. Without these two, without the infrastructure being in, I cannot bring in Puppet. So that is why there is a clear distinction between the infrastructure layer and the configuration manager. Now, using Puppet, I could further install other applications like your Apache or your MySQL or maybe any of message queue server. And then further I could deploy my applications itself. So, but all this will come post your infrastructure layer, and that's why we are separate here. So once this is deployed, once your applications are deployed through your Puppet and stuff, the next thing is you need to monitor them. Now, how do we monitor? So monitor, we have a separate set of infrastructure. Now, this is one of the most important aspects of DevOps, and I will come back to that example which I gave in the webinar, and let's see how this monitoring plays in this whole layer. Okay, so let's take this again, this example of okay. I mean, instead of going to an e-com, let's get into the example of today there's a cricket going on, right? And you would rather expect some standard set of users trying to log into the one of the sites, maybe ESPN or whatever that may be. Suddenly, because of some activity within the cricket field, the number of it surges, right? When it surges, we all know everything has been designed for some number of users and etc. If there is surge, the surge cannot be handled. Correct? It can't be handled. So people are in. This is what happens. People will be like, if you've been booking IRCTC. I mean, if you're booking a rail ticket through, you all know that how you get into the queue on a Tatkal day. So that's exactly what would happen in a website. Now, how do you handle such a situation? Now, in this situation, what DevOps would do is, first, I would create a new VM. I will provision a new VM. Then I will configure that. I will use Puppet and install my application. Then I will connect him to the web, to a load balancer. I will connect him to a DB, and then bring him online. Now, all of this is happening without you interfering. Now, how do you make all these things to happen? So I use the monitoring layer. The monitoring layer will tell that the number of users at this moment is gone beyond for the infrastructure to handle. If this was designed to handle 1,000 users, we have already 1,100 users. Now I cannot do it. So the monitoring layer then goes into the backend system and triggers an event saying that the users have gone up and we need to build a completely new system to handle that many users. Now, how do you do this integration of event when a monitoring agent triggers an event? The event goes into the infrastructure layer. It creates a VM. It creates a Puppet. So you know this complete pipeline has to be developed by these DevOps engineers, and that is why I again now say I give you another use case where you require strong coding, you require strong networking, and understand this whole integration, how this is happening. Okay, so I hope now you could get a better picture about how this whole systems are integrated now. Yeah, can I install? So Habib has a question. Can I not install Windows or Linux OS using Puppet? Okay, here is the question. So here is the answer to that, sir. Operating systems for bare metal needs to be provisioned through the infrastructure software. When I say infrastructure software, that includes PXE, DHCP, and your Kickstart utility tools. So a bare metal can only be provisioned that way. But if you are thinking of provisioning and always using Puppet, then we are talking of the virtualization layer. So your hypervisor needs to be installed through a infrastructure automation layer, whereas your VM can be installed through your configuration management layer like Puppet. So that's how you differentiate here. Hope this is making sense. Is that I mean, this is a very good question. I think I probably skipped while answering this whole situation. We need to make it clear where you position your infrastructure layer and where you position your configuration layer. Okay, so the unique problem which we all have and we've all faced as part of infrastructure engineers or developers as we have been in the past. Now, developers always look for a change. See, in today's scenario, everything needs to be in a very active way. Like businesses come back and say that they want a particular feature to be started, to be launched in just a week or 2 weeks and things like that. Now, this has not been the case earlier. Everything we used to take a lot of time on how to go about doing it. So now, this has not been the case as such. So developers always look for changes. They try to implement every new techniques introduced. Whereas operations say change is the enemy for operations and is not reliable and leads to instability. Now, where does the DevOps going to come and fit in? And was DevOps earlier there to solve these problems? See, now much before this word DevOps came in, we already had automation or the word was automation then at various levels. I mean, if you just go back in time, we always had this network interface cards which came with a option to install over the network. Now, this existed even much before many of these organizations adopted the so-called concept of DevOps. Now, what was that introduction of this network-based installation? So network-based installation was one of the first attempts to start work in an uninteractive way. So that you don't require a lot of attention of the operators to get some work done. With this way, we make sure that we could just need, with a click of few buttons or so, we would get the work done. So this was one of the starting points of the automation that came in. But was automation only at that level? Where do the development aspect come into those kind of automation? So that's what we want to see as we go in a little further. So difficult to integrate, so DevOps problems, so difficult to integrate tools, very less interest in learning other tools, different implementation of similar tools. Now, we know that the DevOps, the development tools and operation tools are two different things. And there was never an integration between these two at any point in time. So the dev tools basically comprise your development, your IDEs, your version control system, and the compilation units. Now this is what would constitute your development platform. And then once this is compiled, you would then need to put this particular you need to have this packaged. This package, put into some other place from where which we could source. So if you're kind of familiar with, if you're looking from the Unix background, we had these packaging tools like Yum and RPM, etc., where you had these tools which are kept. And if it was not so much on the Windows side, I mean, Windows also would have an equivalent kind of a tool, so where we could have all these packages installed, and so is the case with the op guys also. So op guys also have their own tools. Now these tools are primarily to manage these packages that we have built. Example, like if you have your the dev have created their package, and then we need to install them, we need to configure them, and then we need to monitor them. Now, so as you see now very clearly that so there are very clear set of tools for the dev and for the ops. And now how do we integrate them? So that was the question which remained unanswered for quite some time until these bigger, until the web scale kind of architecture had kicked in. So when, earlier we were only dealing with, maybe 40 servers, 50 servers, 100 servers. So there, we didn't have so much of a problem working in an isolated way where devs would do their job and ops would do their job. But when the servers have ranges in thousands, somebody thought about this is not the way to work. Okay, we have to bring in some kind of integration. So that's where this whole thing started about. Development. Now this is the classic case of how the earlier way of operations would work. The development team would send out its code based on the requirement, and then the ops team would then install. The classic case of installing any app. Let's say you're installing Apache. So you download the app, you would install it, then configure it, and then you test this particular app is working or not. So now that's the classic case how it should be. Now, is this okay? Is this the way that we need to work generally? This is the question that would arise as a part of the today's new infrastructure requirements. And And is there a way I could bring in some kind of consistency in this kind of operation? So if I were to be doing this for more than 100 systems or so, can this work? Can this really work? So can this really work? So developer gave a faulty artifact, and so the so whatever was deployed was bad, and then the operation teams wouldn't. So now if you look at the scenario here, now the operation team would not know what could have been the problem. So from his point of view, he will check his parameters. So that would be to check whether all the basic necessities are up and running. Like here, if it's the operating system, check your OS is running, the server, to check if your servers are up, your storages are up, and all that may be required if it's and primarily these are web servers, to check if the web servers are up, if the IP is configured correctly. All these things is only these kind of activities is what the operations people can do. Now coming to the development side of it, his job is to look into the code assets, and he will not look into any of the operational part here. So now you see that if these two people were sitting together, there would have been a great synergy. So the dev would know where exactly he can really isolate from the dev side if it's on the code aspect, or operation guy can then check if it's on the operations aspect. So when they both sit together, that's where you get a different scenario of operations, which we've not seen earlier as such. So the developer is working on his machine, but he's facing some firewall issues for a local tool. I mean, this is the basic thing which I was just talking about, whereas he reaches out to a local IT team and they point out to the infrastructure team, and then finally the issue is resolved. So here, how when both of them are sitting together, they are able to handle the situation better, because each one is able to isolate the problem from their respective areas. Operations team will give their analysis on if a problem exists, and the dev team would give their analysis on how it would actually be if it was all working together. Okay, so after deployment, so developer checks in and figures out that the correct DB was not deployed, whereas the operations after deploying during test, after few scenario tests, see some anomalies and raise some defects. So so by now, I mean, you're able to kind of see where each one actually is able to work in their individual space, and yet to bring in synergy here. So there is clear now. I want to emphasize here there is a clear-cut difference between both the people, but they operate in their isolated way, but yet integrated together. So nobody gets into the other's job as such. They are still working on their own way. But what comes into the picture here is the way they operate, and way the operators themselves manage these entire systems. Because scenarios we are looking here is not like the only scenarios where we have 5 servers and 10 servers. We are looking into hundreds of servers. So the way they operate has to be in a different way compared to what they have done previously. Now, yes, if something has gone bad, and then we roll back. So that's the standard procedure in any of these operations. Now, what I want to emphasize here also, imagine if this code had gone to, say, 100 servers, and you want to roll back, and you want to do this is if less than 5 minutes, 10 minutes, because if it's web side of it, how many number of people come per minute, right? So how would you do this? Now this is where the tools come in and change the way the DevOps itself operates. If I want to bring back this in 5 minutes, now can we do this in the traditional way where you go and manually change it, or how do you get this done? So DevOps is not just about operations. It's also about using tools to get these operations in place. Like as I said, rolling back of 100 systems. How do you do this in minutes? Now, we can only achieve this if we do an operation the way is in DevOps and have those tools to get this complete synergy going. Who does the build? Okay, so the build piece still lies with the developer. So the build, he actually now, I mean, today even the build piece gets actually automated. So somebody checks into one of the version control system, then it is checked out, compiled, build it into a format, and then pushed it into the provisioning system. So this whole process itself actually gets automated these days. And to do this process of automation, now here when I say process of automation, that is build. When I say build and package and push it into the deployment tool. So most of the time this is kind of handled. This is normally handled by the developers themselves, but I know of scenarios in bigger organizations. The build automation is also handled by the DevOps engineers as such. They can do the build as well if a requirement arises. But normally, I have not seen cases where the DevOps handle the build. They start from the package. That is, once the package is created and they push it into a deployment tool, like as you said, a YUM or an RPM or whatever. We start from there as such. Okay, now I'm sure with all of these questions and the answers to them, we understand where DevOps is, right? As I again emphasize, development guys continue to be developers, whereas it is the operations guys who are enhancing their skills to meet up to the level of an automation engineer, where he has to imbibe the coding skills so that he can use coding for operations basically, than for actually the application development. So the application development will always lie with the developer. He would not get into the operations in any way, except for fixing up problems and things like that. That is where when they come together. But it is the operations guys who enhances his skills than actually the developers who enhance their skills. But that doesn't stop a developer from coming into the DevOps space. So, but moving into a DevOps space, then what it means is he is leaving his existing dev work and moving towards an operations side of it. I hope this is making clear to everybody now. Okay, so now that we have kind of seen where the whole issue of DevOps and dev and operations are coming together. So let me just read this out for you. So dev is used as a shorthand for developers in particular, but in practice it is even wider, and it means that all people involved in developing the product. That includes your product QA, packaging, or any other kind of discipline. Whereas ops in a blanket term means systems engineers, administrators, operations staff, release engineers, DBAs, network engineers, security, and various other titles or disciplines that may be. So the word DevOps, I know it confuses, saying that it seems to be that the operations guy will also get into the development and the developer guy gets into the operation. It is not the case. So that's what I was trying to emphasize here a lot. They continue to maintain their individuality, but they work in a more synchronized and more cohesive way together. But what we see here is the ops engineer who, if you take a lot from a background out here in India, he would mostly be a DBA or a Unix guy or a network guy or a storage. Now, this guy would now need to add in much more skills and more importantly, add development skills as such. It's only if he had the development skills is when he is able to automate and he's able to think how to automate. So that's most important here. So we have another 2 more questions. I prefer to answer them. Actually these clears a lot of doubts of so many people. These questions are very interesting as well. So that's why I'm doing a little emphasis on answering the questions as I go through the slides as such. Now, Habib has a question here on the layered products. Is the expectation that DevOps engineers should know OS and also all these middleware technologies? Yes and no. Okay, I'll give you a scenario which I used to work at. Now, does he need to know middleware technologies? Yes, and I'll give you an example. So, I worked in an environment where there were 100 web servers, okay? And I had to ship these log files from these servers and consolidate them back into. See, I know we have other tools like the normal syslog configuration tools and stuff like that. Now, if I had to ship them, I could also use these tools, or also I could write in my own tools. Now, imagine a scenario. I think I could more probably take up the error log message files. I think let me take on that than Apache log. Now, every system creates log messages files in a file. Could be a D message or var log messages. Now, I have to ship them and analyze them. Now, if I had to ship them, I could do the normal systems operation of copying from one machine to another and then get it going. Now, imagine if there are 100 servers and then I'm trying to put this all into a single server. Now, that's not going to work in a right way. And I don't want to ship the entire files as well. I just want to ship only that difference of data which has occurred since my last movement of the data. So how do you do this? Now, you need to have some skills on an MQ for you to read that just generated log and ship it. Okay, so you need to have. So now I wrote this using a RabbitMQ and using a Perl as my tool to take the difference of files, put into my RabbitMQ server and ship it onto the other end. So yes, so if I ask you, yes, but he does not need to know a WebLogic or a WebSphere app server. He just needs to know any of these open source. And most of the time these are, we today use open source tools to manage all this. Yeah. So again, going back to the question, I think which Kishore asked. Yes, do we need to know more? Yes, we need to know more. We need to know OS technology. We need to know middleware technology, we need to know your web technology. We even need to know pretty deep level of networking as well as security. Okay, so of course I'm going to come to the security. I mean, not to deep level, but to some level. But you need to know networking at a pretty decent level compared to what you have probably learned previously. Okay, so now DevOps has a solution. Instead of seeing these two groups as silos who pass things along but don't really work together, DevOps recognizes the interdependency of software development and IT operations and help an organization to produce software and IT services more rapidly with frequent iterations. Now we see that there is definitely a requirement for the synergy between these two. So what happens in a DevOps environment? The developers, the operation engineers, and the business team all work together in a more cohesive way than they've ever done before in other environments. So this is the kind of first test towards having more closer integration among all these guys. But again, I need to emphasize here, nobody's getting into others' job, but primarily helping each other to understand their domain better. But more importantly, the operation guy's skill has definitely enhanced to get this whole process in place. That is one point which I need to emphasize here. And also, a developer can get into a DevOps job, a business guy can get into a DevOps job, or a systems guy can get into a DevOps job. So DevOps is definitely a different set of skill sets. I'll come into that a little later on what are the skills and all that. But yes, it's a unique skill set to have, and it has a lot of requirements in terms of how you want to push in all these tools there. Okay, so now mindset, the DevOps challenges. Yeah, DevOps is not easy to implement in an enterprise, but in an internet organization, that's there by default. We don't have a choice. Getting this into an enterprise is a bit of a challenge because of various things. One is the technical challenges. People are even today. I mean, when we see when do you get DevOps? I'm sure if you have gone through an infrastructure life cycle, you know today all organizations are consolidating. Right, we hear the word. We are consolidating our data centers. What do you mean by consolidating our data centers? When we say consolidating our data centers, that means we are actually bringing down the complete server footprint and having them virtualized. So when we virtualize, you are invariably reducing the server footprint. So consolidation is about virtualization, and then once you virtualize, you have the next stage. That is the automation, and that is where the DevOps come in. So where are we today? So today, a large, I think 70 to probably 80% in US have consolidated. Have their data center consolidated. That means they have virtualized their environment. So once the environments are virtualized, the next step is nothing but automation, which is nothing but DevOps. But is DevOps immediately necessary in an organization? May or may not be. And that is where we need to push people's mindset to start saying that this brings in a lot of change. But as I said, see, this also, momentarily, it also reduces the people usage. So because of which there are going to be a lot of challenges as it. See, I'll give you examples. When one of the very big pharma which I worked, it was a predominantly a SunSpark platform, and it was all Solaris, everything about Sun you would find in that organization. One day, the head of IT changed, and he happened to be an ex-IBMer. So this guy decided, yeah, I will just go in for complete IBM. I want to change all of this. Now, when you take such decision, the internal people who were all trained to be on Solaris for so many years did not just like the option of going into a AI platform. Now, so you see that there was tremendous challenges which you would come into such a kind of, and you kind of face that in DevOps as well, because people invariably perceive this to be loss of job. See, momentarily, yes, it looks, but I'm telling you, this creates another opportunity in so many other ways. So when I say when DevOps is coming in, that doesn't mean your system skills or server skills or storage skills are going away. They are not. But you need to reskill to be relevant. That is more important. So why is automation? So Habib had another question. Why automation is not possible without virtualization? Automation is definitely possible automation is definitely possible with virtualization or without virtualization. But what is the difference is the agility what you get with virtualization is much more than in a bare metal form of automation. So as I said, having worked quite a bit on the Sun side of it, we had all these automations during the bare metal phase itself. We had a lot of them, but of course, I can't, see, if I have an operating system installed on a server, can I move that entire operating system to another server if that system were to crash? Now I can't do that because I need to remake that entire OS and put it into another machine. Now imagine if that were to be in a virtualized mode. I could move that operating system seamlessly across different machines because there's nothing going to stop you there. Okay, so this is what is whole thing about automation in a virtualized space as well as a non-virtualized space.